Good day to everyone and welcome to Statistics and Probability Quarter 4, Week 2. So for today's discussion, we will have two modules, in which the first module is entitled Formulating Appropriate Null and Alternative Hypothesis on a Population Mean. So last week, you have learned that there are two types of hypotheses, and these are the null and alternative hypothesis. So but this time you need to formulate it based on the population mean. So coming from the parameter. So after this session, you're expected to identify the notation to be used in formulating hypotheses. Second, illustrate one-tailed and two-tailed tests and differentiate null and alternative hypotheses and formulate null and alternative hypotheses. Okay. So I know that we have already defined what a null and alternative hypothesis is last time. So for learning task number 2, you may do this as an exercises. So examine the pictures below, then answer the guide questions that follow. So I have here two pictures which will show you the effects of fertilizer on plant growth. So the first picture is that, or the figure 1, is a plant which needs water only. It has no fertilizer. So what do you think will happen to the plant if it will just have water and no fertilizer at all? And the second picture is another plant wherein after watering it, you will also apply or put on fertilizer. So what do you think will happen to the plant? So based on the two pictures, what have you observed between the two figures? So obviously, diba? We have the first figure or both of them, seeing the difference between them. The first picture, the plant has no fertilizer, while the second picture, it has a fertilizer. So do you think the fertilizer has an effect to the plant? Yes, you're right. Of course, fertilizer will have a great effect on the plant. So let's say, for example, it will take 1 or 2 days seeing the difference between the two, the one with the fertilizer and the one without the fertilizer. Of course, figure 2 will grow faster than, or plant 2 will grow faster than plant 1. And then third question to analyze, what do you think are the variables shown in the pictures? So in doing a research, it's very important that you know that you must know the different variables, okay? Like in this one, we have the fertilizer and then the plant growth, okay? So you need to identify which one is the independent and the dependent. I know you had your background on research, diba? So we'll discuss that more sometime more. Okay. So fourth question, is there any relationship among the variables in figure 1 and figure 2? Maybe, diba? Okay. So of course, they have relationships, the fertilizer and the plant growth. And how does these pictures relate to hypothesis? So what's the connection of this with our discussion? Of course, this is an example of an experiment. And you know that whenever you're doing an experiment, you need to prove something, and then a hypothesis must be formulated out of the given experiment. So for today's discussion, you need to know first what a statistical hypothesis is. So basically, it is a statement about a parameter, meaning anything coming from the population, and it deals with evaluating the value of the parameter. So it does not stop on knowing the parameter. You must need to evaluate the value of the parameter. So in statistical hypothesis, there are two types of hypothesis. We have the null hypothesis and alternative hypothesis. So we have indicated last week that the notation to be used for null hypothesis is H sub O, while for the alternative hypothesis, we have H sub A. So what's the difference between the two? So when we say null hypothesis, it states that there is no difference between population parameters such as the mean, the standard deviation, the variance, and many others, and the hypothesized value, of course. So usually we start stating the null hypothesis as there is no significant difference, or in any way you want, wherein the connotation or the meaning of the statement will have no difference at all. Okay. Another one is that when we say null hypothesis, there is no observed effect. So in the case of the fertilizer, with or without the fertilizer, it will have no effect at all on the plant. The null hypothesis is often an initial claim that is based on previous analysis or specialized knowledge. While on the other hand, when we say alternative hypothesis, it states that the population parameter has some statistical significance, meaning it can be smaller, greater, or they are different at all with hypothesized value. It has an observed effect. And the alternative hypothesis is what you might believe to be true or hope to prove true. And to state the null and alternative hypothesis correctly, these some steps may help you in stating them correctly. First, you need to identify the parameter in a given problem. What are those parameters? You need to know the value of the population mean, the population standard deviation, the variance, the sample size, or whatever, but anything, any value that comes from the population. You need to identify them properly. And then second, you need to identify the claim to be tested that may show up in null or alternative hypothesis. So the claim based on the problem depends whether it is a null hypothesis or an alternative hypothesis, and it will always be given in the problem, of course. Third, translate the claim into mathematical symbols or notations. So whatever it is, you need to translate that into symbols. That's why it's very important to know the equivalent in words of the different mathematical symbols. Fourth, you need to formulate first the null hypothesis, then the alternative hypothesis based on the three different ways in writing hypothesis as illustrated below. So the first way by which you can state your null and alternative hypothesis in symbols is that the null hypothesis, mu, which is the population mean, is equal to k. So whatever value is that. While the alternative hypothesis is that the population mean is not equal to k. Okay? Another way of stating the null and the alternative hypothesis is that H sub O equals, or where the population mean is less than or equal to k. So meaning less than or equal to, from that value or less. While on the other hand, for the alternative hypothesis, the population mean is greater than k. And another last way by which we can formulate the null and the alternative hypothesis is that mu is greater than or equal to k, and for the alternative hypothesis, population mean is less than k. So you can see now the difference, the different ways by which we can state the null and alternative hypothesis. So in math, different symbols may mean different things. So the table that will be shown will help you in formulating your hypothesis based on the phrases given, or on the phrase given. So you will use this notation, the equal symbol, if in case these are the words associated with your hypothesis. So we have is equal to, is the same as, is exactly the same as, or has not changed from. While this symbol, which is not equal to, of course, is not the same as, is different from, has changed from. Okay, so this symbol naman is greater than and this one is less than. So these are the words associated if you will use the greater than symbol as well as the less than symbol. So please take note of those words. And another one, ayan, this word, many got lost when they encountered these words, is at least or is at most. When we say is at least, in Tagalog, pinakamababa na. So ibig sabihin, from that ceiling point pataas. That's why the symbol is greater than or equal to. While if we used is at most, pinakamalaki na. Ano? So kabaliktaran, no? Pinakamalaki na, but then the symbol will be is less than or equal to. So that's the reason why some got will get this wrong if they will encounter the words is at least or is at most. Okay, so another term which can replace is at least, we have is not less than, is greater than or equal to. While on the other hand, if you use is at most, you can also use is not more than or is less than or equal to. So please remember these words because this will really help you in expressing or in stating your null and alternative hypothesis in symbols. Okay, so another thing that you must know for this module is the difference between one-tailed test and two-tailed test. So when do we say that your hypothesis is a two-tailed test or a one-tailed test? So basically our basis is the alternative hypothesis, how you state your alternative hypothesis. So if you will use the words like greater than or less than, so basically it's a one-tailed test, meaning it has a direction. That's why when we say one-tailed test, directional. Greater than meaning going to the right, less than going to the left. That's why it's directional. So a one-tailed test can either be a right-tailed if you use the word greater than, or left-tailed if you use the word less than. Okay? While it will be a two-tailed test if the alternative hypothesis is stated using the symbol not equal to. And it has no direction because you do not know whether the value of your population or your parameter will be greater than or less than that value. That's why it has no direction. Okay? So it's a one-tailed test and two-tailed test. So this table will help you analyze whenever your alternative hypothesis or your null hypothesis is a two-tailed test or one-tailed test, and then the symbols to be used. So if you have two-tailed test, usually the null hypothesis will be stated using this symbol, the equal sign. And two-tailed because your alternative hypothesis is not equal to, diba? The given value of the mean. The population mean is not equal to that value. But if it will be a one-tailed test, so these two columns, one-tailed test, it will be right-tailed test if your null hypothesis will be stated as equal or less than or equal to, and your alternative will be greater than. Okay? And then left-tailed test if your alternative hypothesis will be less than. So these are the symbols that you can use, right, in stating your null and alternative hypothesis. Okay? So moving on, let's have example 1. The average waiting time of all customers in a restaurant before being served is less than 20 minutes. Determine the hypothesis and the directional test. Okay? So you need to take note of the words is less than 20. Okay? So what's the first step? As stated in the steps that I have discussed to you, you need to identify the parameter in a given problem. And what is this? Okay? What is that parameter? Okay? So what is that word that will give you a clue? Is it the population mean, the population standard deviation, or the population variance? So here's the keyword, the word average. So that's why if we will take note of the given parameter in the problem, then it will be, yeah, the average waiting time of all customers in a restaurant before being served is less than 20 minutes. In symbols, how are you going to write that? Okay, so in symbols, okay, so we have the population mean is less than 20. So that's the symbol, the equivalent in symbols, which is of course the step 3 actually. Okay? And what will be our claim? Anong claim natin? Ayan na yung symbol pala. And the claim as stated in step number 3, basically is less than. So this is your alternative hypothesis. Ayan na po. So your null hypothesis can either be the population mean is greater than or equal to 20 or just equal to 20. Okay? Nawala po dito, nagkulang yung ating symbol. It should be HO is that the mu equals 20. So those are the different ways by which we can state your alternative hypothesis. But of course, as given in the problem, basically, since we use the word is less than 20, so it will be your alternative hypothesis, and that will be our claim. Okay? So, and since it uses the symbol less than, meaning it's a one-tailed test, specifically a left-tailed test, because it's less than. Okay? So that's how we analyze a given problem, whether it will be a one-tailed test or a two-tailed test, and of course, stating its null and alternative hypothesis. Okay? So let me just erase the annotations that I have included. Okay. So to continue, let's have the second module, which is identifying appropriate test statistics involving population mean. Actually, you know this already. Remember the activity to Z or not to Z? Okay, so it has something to do also with this. Okay. Yeah. So these are the objectives. You need to define the statistical concepts related to tests concerning means and identify the appropriate form of test statistics whenever the population variance is assumed to be known, the population variance is assumed to be unknown, and the central limit theorem is to be used. And lastly, apply the concepts of test statistic on real-life problems. Yan. So I have here an example where we tried to take note of the different notations. Okay. So as you can see in the problem, it states that a grade 11 researcher reported that the average allowance of senior high school students was more than 100. So what happened? Average. So meaning that's the population mean. Okay, the 100 pesos. Then a sample of 40 students, meaning your N, the small n is 40. Okay, had mean allowance of 120. So that's the sample mean is 120. So alpha, or the level of significance, is 0.01 test, and that it was the claim that the students had allowance of more than 100 pesos. The standard deviation of the population is 50 pesos. So in symbols, we have this. Okay? So kiniklaim yung 100 po, that's the claim only. Okay? That it will be more than 100 pesos. Okay? And so, with this module, you need to know if the population variance is known, then you need to use the z-test. If the population variance is unknown, we need to use the t-test. And if your n is sufficiently large, then the last resort is the CLT, or the central limit theorem, where you can use the z-test by replacing the population standard deviation by the sample standard deviation. Okay? So because if the variance is known, then the symbol will be this one, the sigma. Okay? But using the central limit theorem, then you will use S for the standard deviation na. It's a z-test pa rin. These two will use the z-test formula. Okay? But they will have different notation. Remember the formula for the z-test? The population mean minus ganyan. Okay? Yun na yun. So as for this example, a study was conducted to look at the average time students exercise. A researcher claimed that in average, students exercise less than 15 hours per month. In a random sample size, n equals 115, it was found that the mean time students exercise is 11.3 hours per month, with S, or the standard deviation, of 6.43 hours per month. So let's now try to analyze this problem. So basically, what are the given? First and foremost, the random sample size is n equals 115. So obviously, it's very large. So with that value, by just looking at the number of the random sample size, then we can conclude at once that we need to use the CLT. Okay? And in using the CLT, we will use what test? It's the z-test. Okay? So to sum it up, solving this problem, yan, knowing what test to be used, then we have the z-test. It's the appropriate tool to use because, or since, the sample size is too big, or it's really greater than 30, which is 115. So that's the reason why we need to use the z-test. Okay. Let's have this second example. An English teacher wanted to test whether the mean reading speed of students is 550 words per minute. A sample of 12 students revealed a sample mean of 540 words per minute with a standard deviation of 5 words per minute. At 0.05 significance level, is the reading speed different from 550 words per minute? Okay. So basically, by just looking at the sample size, there are only 12 students. So your N is less than 30. And if that will be the case, what test is to be used? Yes, you're right. It's t-test. So we need to use the t-test since the number of sample size is less than 30. Okay? So as easy as that, all you need to do is to identify what test to be used based on the number of sample size given. And of course, aside from that, the population variance is unknown. Okay? So since the population variance is unknown, then we need to use the t-test. And for our last example, a manufacturer claimed that the average life of batteries used in their electronic games is 150 hours. It is known that the standard deviation of this type of battery is 20 hours. A consumer wished to test the manufacturer's claim and accordingly tested 100 electronic games using the battery. So it was found out that the mean is equal to 144 hours. Okay, so reading and understanding the problem, it seems that there is no sample size given. But what's given? Ayan, this one. So what kind of standard deviation is that? The 20 hours. Coming from the population or from the mean? The sample mean. Okay? Or from the sample. So obviously, based on, since it's the second sentence, knowing that the average life of batteries is given or came from the population. So obviously this is standard deviation is the population standard deviation. And so if the population standard deviation is known, then we need to use what test? Yes, it's the z-test. Okay, so see now the difference on when to use the z-test, the t-test, or the central limit theorem by using again the z-test. Okay, so I hope you understand the two modules for this week. And so for your learning task number 3, so just do learning task number 3, okay, which is entitled Check It Out. So based on the 5 problems presented, you need to identify, yes, one, if the n is greater than or equal to 30, if it is less than 30, if the population standard deviation is known, if it is unknown, if it is z-test or t-test. You need to check, okay? You need to check which column is appropriate for each given problem, okay? Just identifying lang. And for your learning task number 4, yeah, complete the following sentences by filling each blank with the correct word or phrase. So with the 2 modules, I hope that you have learned something again from me. And so we'll see each other again on week 3. Goodbye, everyone. Have a nice day.